Hello, in this tutorial we're going to manage a collection of enemies. So in the last tutorial what we did was expanded our main game by adding these 3 enemies, and then we initialized each of them here, and then we made sure that each of them were updated, and then each one of them were rendered. The problem with this is, what if we wanted more than 3 enemies? So what we'd like to do is be able to manage a collection over a data structure that manages these enemies. And the way to do that most easily is to use a built-in data type called the list. Now, a list is a parameterized data type, and what it does is inside of this less than, greater than brackets, it's going to say what kind of thing do you want to store in this list. And the list can grow and shrink, and we can add things to it and take things from it, and it'll automatically manage the memory that's required to deal with holding whatever we want to place into it. But we do need to say what kind of thing we want this list to hold. So we're going to say that I want a list of enemy, and enemy is the class of thing that we're going to have placed into this list. So notice the data type of the class that we had here for E1, E2, and E3 is enemy, and this is our class enemy. So I want the list to hold things of type enemy. And I need to give this a name. So list of enemy is the type of thing I'm going to have here, and now I need to give it a name. So I'm going to call it enemies. Now, since I'm going to maintain this list of enemies, I don't need my individual E1, E2, and E3 variables. I can go ahead and delete that. And so now our game, our main application, has this list of enemy that's going to be called enemies. Now, the first thing I need to do inside of my initialize is then fill this up. Now, the first thing I need to do is actually make sure that that list is in existence. So I'm going to say that enemies is equal to a new list of enemy, and that's going to establish a space in memory for that list to hold new items that I place into it. And then what I'll do is I'll create an enemy E, and I'll use that enemy E as a local variable to create new instances of the enemy. Okay, so now we've got 3 definitions of new enemies, but before I create new ones, because this second one would just wipe out the first one and this third one would wipe out the second one, what I want to do is create a new enemy, and then I want to add it into my list. So enemies.add E. It's very easy to actually add something into my list, because enemies is the name of the list, and then I'm going to invoke the add method, and then I need to pass it the kind of thing that I want to add. So in this case, I'm adding this new enemy that I created into the enemies list. And I can just repeat that every time I create the new enemy. I'm going to create a temporary new enemy called E, and then I'm going to add that into my enemies list. Now I can use this same variable E, because once I've added it into the list, if I use E to point to a new enemy that I've created, that one that I added into the list is still being held by the list, and it's not going to go away. It's not going to automatically be deleted. So here, I'm going to use this temporary enemy E variable. I'm going to create a new enemy and have E point to that, and then I'm going to add that enemy into the list, and now it's up to the list to manage that piece of memory that represents that enemy, and I can reuse this E variable to create a new enemy and add it into the list, and so on. So here we have the 3 enemies. E is being used 3 times, and now the enemies data structure, this list, is going to contain 3 enemies. So now I don't have E1, E2, and E3 for my update, so let's delete that, but I do want all of the enemies to update themselves. And so now I'm going to use a looping structure, and I've got this for each structure, and I'm going to say for each element in this collection I want to do some work. So I'm going to say for each enemy in my collection, I want to do something on that. So the for each structure works like this. It says, here's your collection, right? My enemies is my list of enemy type, and for everything that's in that, I need a temporary variable. Let's actually call this E again. So I need a temporary variable of this particular type to work with every time I pass through this repetition structure. So I want to do work on each enemy in my enemies collection, and what do I want to do? Well, just like we were doing with E1, E2, and E3, I'd like to update them. So I'm going to use this E variable here as a temporary name, and as I iterate across, or as I go through the entire list labeled here, it's going to use E as a temporary name and then I can do work on that enemy. Now, strictly speaking, I don't have to use the curly braces here because I'm only doing one statement. So very similar to my conditional if statement, I don't have to have the curly brackets if all I'm doing is one thing. So I could just say for each enemy, E in enemies, do the E.update, or I could have the curly brackets. In particular, if I wanted to do more than one thing on this E, I would need to use those curly brackets there. Okay, and very similar down here in the render, I'm not allowed to reference E1, E2, and E3 because I don't have those variables anymore. So I want to use my for each again. For each enemy E in enemies, what do I want to do? I want to do E.render. I want to make sure that all of the enemies are rendered. Now, don't be confused to think that we have to use E as a variable name here. I could call it whatever I'd like, so long as what I'm calling it here for the temporary is what I'm using inside of this loop as I iterate across. The one thing that does need to match here, though, is that the enemies, this is the collection. This is my list of enemy that I have, and this list is of is holding the enemy type. So these things need to match up. So I'm going to put my curly brackets in here just to remind you that I could either leave it off like I've done here, or I could add them if I'm doing more than one statement. Okay, so now what's really cool about this is in my update and my render, it doesn't matter how many enemies are in that list, it's going to do this work for all of them. So as I add more enemies, it doesn't matter how many I've got, this code is going to work, and I don't have to have an individual variable for each one of those. I can just manage it in this collection. So let's run this and see what we get. And we've got our enemies coming at us just like they were before. And you should say to yourself, well, there's been nothing different now, so why all this work? The advantage, though, is that now that I'm maintaining this list of enemy, I can add as many as I'd like into that collection, and my code here for my update and my draw is always going to work. So I don't have to worry about how many there are, it'll just automatically work there. So to prove that, let's add a fourth enemy. Up here in my initialize, I'm going to add a fourth enemy, so I'll just repeat this structure. And let's place it a little bit higher up on the screen, and we'll see if we run this now. Right, our list of enemies is working just fine. I've got 4 enemies now. What's nice is I didn't have to change my update, I didn't have to change my render code. All I needed to do was add a new enemy into that list, and now I've got all of these enemies coming at me. The list is managing them appropriately, and my for each loop will automatically iterate across that entire collection and do whatever work I tell it to. Okay, so as a review, we haven't changed the enemy class at all. That is the same as it was before. The only thing I did was I removed that E1, E2, and E3 enemy. I created a list that holds things of the enemy class, and I called that list enemies. Then in my initialize, make sure that you don't skip the new command so that I'm allocating memory and creating space in memory so that this enemies list can be managed. I used a temporary enemy variable called E, and then I used that 4 times to create new enemies, putting them in different spots just like we had done before, and adding them into that list after I created it each time. We then used the for each loop inside of our update and inside of our render, and we iterated across the entire collection here, and then we told each one to update themselves, and then we told each one to render themselves. So no matter how big the list gets, this code will always work, and it will always iterate across all of the elements that are in there. And that'll do it for this tutorial. In the next time, what we'll do is add random enemies at different times so that the enemies will continually come at us no matter how long we've played. We'll get more than 4 enemies, and we'll be able to easily add them into this new list collection that we have.